Okay, I think we are live. Welcome everybody to the August 18, 2023 meeting of the Node.js Node-API Working Group. Let's go through the agenda, which I will do by sharing my screen. Quick share. Okay, there we go. No, that's not what we want. What we want is this guy. All right, so let's see. First item is the drive towards full coverage. I think Jack is working on that, but since he's not here, we can skip that. Then list of non-C language bindings. Have we found any new non-C language bindings? I don't think we have. Last one was in April. So no news there. Let's see. Debug testing, that's on Michael. He's been working on it or trying to work on it for a while, but since he's not here, we won't be able to update that issue. Now let's see about stale issues in Node add-on API. See if any new ones have popped up that we need to discuss. All right, let's see. Okay, so we have these two issues. I don't know if anything has happened since last week, but yeah. Okay, should handle exceptions. Oh yeah, okay. Yeah, we've I think
Yeah.
we had a PR about this.
Yeah, go ahead. We have fixed the C++ exception handling in the Node.js API, but I hadn't got a chance to look to make the flag in Node core to be the enabled by default.
Oh, okay. Okay. So we cannot quite remove this issue yet, correct?
Yeah, exactly.
Okie dokie. All right. Okay, this landed. Okay. All right, I see. Okay, sounds good. All right, and the other one, this one I think has to do with pure finalizers, if I'm not mistaken. Yep, this is pure finalizers, and so we need Vladimir's PR in Node for that, and we're probably going to talk about that. Okay, so that's the stale issues, these two. So then, all right, so now let's go through the new issues, if any. Okay, so this is in Node add-on API. I should just go there. Okay, do we have any new and interesting issues? This was 2 days ago. Interesting. Okay, so let's look at this one. We didn't. Oh yeah, Kevin looked at it. Okay. Yep. That's a good comment. All right. Okay. Looks like Kevin is handling this one. Okay. All right. We're good with this one, I think. Did I go back or did I go different tab? I can go back. Okay. So yeah, this is one I filed. Maybe we can talk about it a little bit. So I had this idea that if we're going to have Vladimir's pure finalizer PR, then because Node add-on API is C++, we might be able to detect at compile time whether the body of a finalizer provided by the user does or does not make use of those Node APIs which require JavaScript capability. And if it doesn't, then we can automatically attach like a pure finalizer. Whereas if it does, then we attach an immediate finalizer. And so what we can do, what I was thinking, and please shoot it down if it doesn't work, is that we can have two different kinds of environments. We can have a regular API environment, and we can have like a JS capable API environment. And those Node APIs that execute JavaScript and therefore need to be JS capable during a finalizer, they accept a JS capable environment. Whereas, you know, the other APIs accept the regular environment. And so we could add the method which attaches the finalizer. We could, that could be like a private method or something like that on the environment. And then we can have two different implementations of attaching a finalizer. One of them that uses pure and one of them that doesn't. Like on one class, on the environment class, we have a method that attaches a regular finalizer, and on the regular environment class, we have one that attaches a pure finalizer, and on the JS capable environment class, we have one that attaches a non-pure finalizer, a regular finalizer. And so, you know, people's ideally add-on maintainers who don't use any of these JS capable Node APIs in their finalizers can just recompile their add-on, and all of a sudden they won't have these memory issues anymore, because they are now able to free all their objects synchronously. That's one aspect that I'm hoping we can do with like C++ templating magic and whatnot. The other one is that if you attach the finalizer by hand, and you attempt to attach a pure finalizer, like if the user code calls for attaching a pure finalizer, but the body calls Node APIs which require a JS capable finalizer, then that will fail to compile, because it's like, you're using the wrong environment for attaching this finalizer. So what do you think? Do you think this is possible with C++?
I guess it's possible. I guess my question, like how we want to name it. We want to name it like a keep environment as we have for most JavaScript related operations, and just rather introduce new like a pure environment, or like Node.js environment.
I went the opposite way. I went with environment. So I went with environment and JS capable environment. So the environment is by default pure, and then we have a second. So far, like I started working on this, and all I did was just alias. Like I said, using JS capable env equals an API environment for now. So they're both identical, but basically a lot of code changes are just like replace, you know, and that's work that needs to be done no matter what. And you have to like create a list of Node APIs which require this, and then, you know, see where those Node APIs are being called from an API inline.h, and just replace it. And you won't be able to tell the difference, because there is no difference. It's just an alias for now. So I think that's a first step that we can do even without having like actual pure finalizer. But in the end, I'm not sure. I can't see the end of this, which is like, okay, if they are not aliases of one another, then what are they in order to achieve this kind of behavior?
I tried to make a list of APIs which do not call JavaScript. It might be not accurate list, but I think I identify like 17 functions.
Yeah,
it's a very kind of small list. It's more like about practicality. Like people today using this API environment, and if we want to rename everything code can use JavaScript, effectively we have to, like you said, change almost all places.
Yeah. So I was thinking, and actually I was wondering if we could use like type inference for this. So basically, and this may not be possible. Basically, the finalizer receives an environment, right? An API environment, And when we compile the finalizer, we infer whether that finalizer is one that receives an NAPI environment or a JS capable NAPI environment because of what it contains, right? And then if it receives if it's supposed to, if the compiler infers that it's supposed to receive a JS capable environment, then we use the JS capable environments create finalizer method or some kind of method to actually construct a finalizer for it. Whereas if the compiler infers that it receives a regular environment, then we use the regular environments create finalizer method, which will result in a pure finalizer. I don't know if the type inference can be used like that. And then as far as the user is concerned, it's an NAPI environment that they receive, but so that's why they don't need to make any code changes, because they already have something that says, you know, this is a finalizer and it receives an NAPI environment, and I don't know, it deletes a class or whatever, right? But I don't know if we can make it so that the compiler can infer that environment is maybe like it's pure or not pure. That would be ideal, because then the user would have to make no code changes and they would get the pure finalizers automatically as soon as they recompile.
Yeah, unfortunately, oh, I see what you're saying. So technically, in C++, it's possible to say that function returns outer, right? And if we can somehow to return some kind of type from some function, and we can decide what it does. Yeah. So your idea, like we keep an API environment for kind of for the user all the time.
Yeah.
Do some kind of C++ template magic, which can decide every specific finalizer if it's pure or not pure.
Exactly. Yes.
I see.
Yeah, I don't know if it's possible. But it would be a really, really cool thing to do, and it would automatically fix everybody's add-ons who destroy these objects in a tight loop. They would just all of a sudden start to work. You recompile them and boom, they start to work. You know, without them needing to like go in there and replace, you know, environments with like pure environments or JS capable environments or anything like that. Yeah, it's anyway, okay. So
technically the way it could be potentially be done, if this finalizer says receive environment as a template.
Yeah.
Right. So in this case, we can potentially do some kind of calculation. So imagine we can have like two different environments, and one environment inherited from, and it's actually two different environments inherited from same base class.
Mm-hmm.
And we can just simply check at compile time if this specific function receives one environment versus another, because if we're using any method which is not usable in one scenario, another, we can just simply have some sfinaya doing some magic. But we need essentially to change signature of all these finalizers to be kind of calculatable, if you like.
Yeah.
In this case, it should be possible, because yeah, we will use effectively this sfinaya, whatever, like sfinaya method to say, like, if it's we could, for example, try to compile it with some environment which is pure, and if function fails to compile it, we just we use another method.
Yeah, that's the other benefit, right? Like if we cannot make it completely transparent to users, then at least we can you know, give them a tool that says that this finalizer is supposed to be pure, so it accepts. They write the code that says it accepts like a pure environment, and if in that code they make a function call that says that ultimately results in a non-pure Node API being called, then the compiler will fail because it will say, you know, no signatures of this particular method except like a pure environment. And so you call this method, but we don't have any overrides which accept a pure environment, and so fail. You know, so if we cannot provide the benefit of automatically fixing their problems, at least we can provide the benefit of them of getting a compilation error that, you know, that they used a non-pure Node API inside what is supposed to be a pure finalizer, and we know it's supposed to be a pure finalizer because it accepts a pure environment rather than a JS capable environment. So that's it's not as big of a benefit as like the automatic fix, but it's still a benefit, you know, because people will understand the difference hopefully between like JS capable finalizer and a pure finalizer. And they will want to choose the pure finalizer if they want like the synchronous behavior. And this should give them the ability to sort of self-correct.
Yeah, okay. The only kind of question, if we can change signatures of finalizers to use environment as a template parameter. Yeah,
that's a good question, right? My first thought was that we could have like a template parameter with a default value, defaulting to either capable or pure. We can pick one, and then you I think you can omit the template parameter if there's a default, and so the code would look the same. It would be an API environment, but I'm not sure that might also mean that it always evaluates to that one, and we cannot really infer. But yeah, that's where the template magic comes in, and I'm not sure that I know enough about template magic to make this work. I just realized that it might be possible. So I'll dig some more during the week and try to make it happen. Maybe just do like a dummy thing, just like a couple of classes from scratch, you know, not using the actual headers, because then I may have to make a large code change, which ultimately doesn't work. But yeah, so I'll try to basically bend the compiler backwards to make this work and see if it will bend or if it will break. But yeah, that was it. Let's see if there are other issues. Okay. So let's see. This was 3 weeks ago. I don't know. I don't know if there has been any movement on this. Let's see, proxy like property accessor. Okay, Kevin talked about this. Oh, wait a second. 114. Oh, I see. Okay. So Kevin answered, and we are looking for a reply to see if Kevin is right or if the person was actually talking about something else. All right. Let's see, operator overload. No. Yeah, all right. I think we can close this one. Okay, yeah, Kevin answered this one. I think we can close it. And this was like on June 30th and no reaction, so. Okie dokie. All right, so let's see. Finalizer callbacks and threads. Wait a second. Oh yeah, this is, yeah. Yep. Vladimir, please land the PR. There's so many people want it.
I don't know, like with ASAN stuff, I don't even know where to start there, honestly.
Yeah, is it happening on Linux?
Yeah, ASAN, I believe we're running on Linux.
Okay. I think there is a configure flag. When you're configuring before you run make on Node, you can like configure like with ASAN, and and then you have to build with Clang instead of GCC. If you configure with ASAN and you build with Clang, there's a good chance you're not going to get a bunch of unresolved symbols at the end when it tries to link the binary. It's not 100%, but it did work for me a few times. So that you can try to do that. So just in like regular Linux, just /configure -- with ASAN. You may need some libraries because it's not going to detect like, oh, you don't have ASAN or something like that. It's not going to detect at compile time. It's going to detect that at link time where it's like, -L ASAN. I don't know what that is. And then you install ASAN and then you run it again. And then hopefully it will successfully link Node. But yeah, it's been pretty unstable for me trying to fix ASAN issues. Another thing you can do, if it's happening, like if it's happening on that exact Linux platform, we may have one in CI, like in the Node.js CI, not in the GitHub Actions, like same version of the same distro, etc., etc. And then I think you can go into Node.js. What is that? We have a repo for infrastructure. I think it's Node.js CI or Node.js Infra or something like that. And you can open an issue there and you can request access to one of the machines, and they will take the SSH public key that you have given GitHub and they will temporarily add it to like authorized users on that machine. And you will receive instructions on how to remove the machine from like the Jenkins work queue. And so you like log into the machine, you type in a command which says, okay, no more Jenkins for now. Then you compile and you configure and you debug and everything while logged into that machine. And then at the end, you delete everything that you did and you run the opposite command saying, okay, Jenkins, take it back and start running jobs on it again. And then when you're done, you make a comment on the issue saying, I'm done, thank you. And then they remove your SSH key from the machine and they will close the issue. So this is usually good for like really exotic machines, like, I don't know, like AIX or Power or whatever, because you obviously don't have one of those in your pocket, right? And
Right.
so you do this, and for the purpose of debugging these problems, you can get an SSH key. But the other good thing about it is that, like if ASAN doesn't work on your machine, you can run ASAN there, and maybe the compiler version and the version of ASAN is just right for it to work. So these are some tools you have.
And using Clang instead of GCC is one kind of flex to make a command.
Yeah. So the way you build with Clang is you export CC equals Clang, and export CXX equals Clang ++ or Clang C++, or I think it's called Clang ++. And so these environment variables they get picked up by make, and you should probably just scroll back in the terminal and make sure that every compilation command line starts with like Clang or Clang ++ instead of GCC, just to make sure that it worked. This trick also lets you do things like Ccache. Like if you say export CC equals Ccache GCC, then it will start using Ccache. So that the same trick works for both. And you only need two. You need CC and CXX because it doesn't use any other compiler from the tool chain.
Okay, yeah, I'll give it a try.
All right, cool.
I don't have the full Linux machine. I typically use this like a Windows subsystem for Linux that we sell.
Oh, yeah. Okay. I'm not sure. Yeah,
The same
it shouldn't matter. It shouldn't matter. But if anything, you can probably just install like a virtual machine with like Ubuntu or Fedora or whatever in the worst case if you need it. But WSL should be good enough, I think.
Yeah, WSL is like virtual machine. So yeah.
Yeah. So if you have the right version of Clang and libasan, it doesn't use any like crazy Linux syscalls or anything. I don't think it's just at the library level. So you should be good to go. But again, I'm not 100% sure. I just feels like it.
Yeah, and if you guys can just simply look at the change itself, or if you find something there, because what I don't like to happen, like we will make this assign clean, and then you guys say, oh, let's change this thing completely, this change completely.
Yeah. Actually,
again for a few weeks. So could you have a look through the change?
Sure. Yeah, I can even try to build it with ASAN on my machine. Because this is a Linux laptop from which I'm speaking right now. So it's a very bad one, very poor quality and very slow, but it doesn't need to be fast. It just needs to work. So I'll try to build your PR with ASAN and see if I can get to the end.
Yeah.
All right.
Yeah, I would appreciate that code review on it.
Yeah, for sure. Yeah. Okay. This is a good plan. All right, so let's see. We should probably go to the main repo as well. So that was this one, node repo. Oh, why did I do that when I can just, well, actually, this is why I did that. Okay. That's strange. Oh, because it's, we got the old label here, so why don't we edit this? There we go. That's better. Okay. Let's see. Crash during thread safe function finalization. Oh boy. That's a fun one. Interesting. Oh, this is an electron. Okay, well, this is one we should take a look at, but who electron, eh? Oh, I remember this one. This is the one where you click on this and it crashes sometimes. Oh, I don't know if we've considered this particular combination where you can have like foreign environments.
My first impression would be, let's say, it might be mixing up two different electron environments.
Yeah, it looks like.
Yeah.
Yeah. Oh, yeah. Passing the wrong pointer, maybe. Yeah. Here's kind of a prototypical PR. Well, thank you, but what do we have currently? Okay, well, okay, so we can look at the code as it is currently and see what the difference is. Okay, so the okay, I don't know what these arrows mean, but maybe this here.
Yeah, it's a proposal. His proposal to fix. So he says he proposes to add this line, and if we add in this line, he says like.
Oh, the context scope, you mean? Because we only have a handle scope now, and we don't have a context scope. This is possible.
Right. It's maybe a real bug we have.
Okay. Yeah. That's fair. Okay.
Have just a PR for that. It seems like
I know, right? But it's okay. It's okay. I can turn this into a PR. Okay. All right. Okay. So this is a good one. Excellent. All right. So let's see. Keep that one open. Interesting. This impacts us.
Doesn't seem to be Node API related.
Yeah, yeah, which is why I'm wondering why this was marked Node API. Let's see what has changed. Node API test policy, that's why. Oh, I see. Okay. It's Node API related because it reduces this problem. Okay, that's fine. Okay, it's tangentially related. Okay, fix compiler warning.
It's always good.
And this is a PR, okay, which Michael has already approved. So that's a good sign. Okay.
Yeah, it's in a pure C++, empty functions must have.
Oh yeah.
I didn't know when I only recently learned this feature.
Oh, interesting. Yeah, this is an old issue. This void versus no void. Okay, I think we can approve this one. It's pretty clear.
I think I introduced this thing recently, but for pure C, if it's empty parameters, C requires to have void.
Yeah. It looks like somebody's compiling with just the right flags to get that warning.
And Microsoft's C compiler, does not follow all the C rules. I often some of my code being compiled in Linux where pure C environment happens.
Yep. Yeah, that's fine. Oh, why is this failing? Well, we can restart that. Okay, so this one looks good.
Yeah.
Okay, so let's see. Data is interesting. Yeah, some activity here. Okay.
It's a lot of work to enable WASM. It sounds pretty
cool.
Like Michael is on top of it.
Mm-hmm. Okay, I think this needs a more thorough review. I'll leave this open, see if there are other issues. Okay, update. Okay, that was this one. Clarify use. Okay, this one has seen some activity.
Why does it have build breaks? It's probably just doc change a few lines.
Yeah.
It should not affect build at all.
No. Okay. Okay. All right. Yeah, we should probably land this one because it's been around for a while. How's it going? Okay, so it has one failed check. Okay. Okay, so lint failed. Okay, otherwise it
some length of some strings.
Yep. Okay.
Makes sense.
Yeah, I'll approve it, but then I'll maybe leave a comment saying, please fix the lint check. All right.
Wait, is it the issue? What Michael said before on this issue? It's something, but oh, okay. Sounds like he updated.
Yeah, he did. Yeah.
Okay.
Yeah, it's done. Yeah.
So.
Yeah, you're right. You're right. Good check. Okay, so that was that. Okay, yeah, this one. I just took a look at this one. This one's good. Changzhong, I think if you can get the test to pass, it's been around for way longer than a week, so we can land this one.
Yeah.
Unless...
And we previously mentioned that we should run CGEM against this PR. So yeah, I'll get a pop around on it.
Sounds good. Yeah, I think the release folks can help you with that, right? With running CGEM.
Yeah, if there is any problem, I can reach out to them to see if they can help.
Yep. Cool. All right. Let's see. Okay, that was this one. Okay, this one is kind of, I don't know if there's been any movement on this one. Oh, yeah, okay, kind of remember this. Yep. Okay. All right, so he's going to circle back. All right. Oh, hey, this is interesting. There's another port of Node.API.
I believe we have released the Node.API headers on npm, right? So
yeah.
I'm not sure if there is any blockers left still needs to be handled before the CPKE can release the official headers.
Yeah. Okay. Oops. Yep, so that's that.
Sounds like I need to follow up on something here. Ooh, sorry, missed it.
No worries, no worries. Yeah, maybe a few questions. Yeah. Yeah. If you could take a look, that would be good. 46641. Yeah, that was this. Okay, well, these are pretty old ones. I'm not sure if there's any movement on these. So I don't know if I think we can just call it for this particular item, and then we can go back to the milestone.
Yeah, it's all other old issues we didn't have much.
Yeah.
Okay.
So let's see. So then the only one that's left is what's new in Node.API Node add-on API World 2023 version. I don't know if any new things have been ported. Let's see. Oh, cool. Yeah, we have a new version of headers. Nice. Awesome. So let's see how we're doing then. All right. Going into the 7 digits. Very cool. Well into the 7 digits too. Okay, so I think that's the last thing we had on the agenda. Let's move this out of the way. And where is it? No, is it here? There it is. Okay. All right. So I think that's the milestone for this week. So do we have anything else we want to talk about? We have about 16 minutes left.
No, I don't.
All good? Okay. I guess if we have nothing else to talk about, then we'll talk in GitHub over the coming weekend once more over Zoom next Friday. So thank you all for joining. Talk to you all later.
Yeah,
Thank
see
you.
you.
Bye.